Meron ngayon.
Okay lang po, sir.
Okay.
Okay.
Para makapag-proceed rin tayo.
Okay lang, sir.
Okay, so sige, no? So let's start today's meeting. Pasensya na kayo, last week hindi ako online, yung mga inayos lang. And we'll now proceed to our second topic. Okay. Wait lang. Topic natin ito. Hindi. Okay. So let us proceed with our next topics. Okay. So this time we'll discuss yung system modeling na tinatawag natin. Okay. So we could have discussed before under this analysis and design objective. Okay. Some of the things that we need to know, okay, especially when we want to talk about what are the major objectives of our system analysis and design. Okay, so when you say system analysis, okay, pag-usapan mo natin ito. Okay, when we say system analysis, this pertains to determining or characterization, bale. Characterizing para din siya. Ayan. When you say determining or characterizing, when you say yung pag binanggit natin yung salitang characterizing, it simply means we want to know, okay, we want to know something about the system. Okay? So ano ba i-characterize natin? Basically, we want to determine or characterize system performance. Okay, we want to know how is our system performing. So this comes with certain things, like for example, time response characteristics. Okay, this should answer how fast. Okay, how fast is the system responding. Okay? So, yun yung gusto nating sagutin sa part na to. Okay, okay. And then, we would also like to know accuracy or basically system error. So, this answers this thing, system error answers how accurate. Okay, how accurate your system response is. Okay. So remember that when we talk about control systems, the main objective of your system is to reach or is to follow the input. Okay? Kailangan masundan niyo yung input ninyo. Okay? And and when you say masundan, it means that, for example, in our elevator example, kapag sinabi niyo pumunta siya ng 4th floor, okay, the system should respond in a manner na dapat mapunta siya ng 4th floor. Okay? Now, there are two questions, there are two fundamental questions that needs to be answered in that case. Okay? Number one is, kung pumupunta siya ng 4th floor, gaano kalapit sa 4th floor yung elevator mo. Okay? Kasi maaaring although malapit siya sa fourth floor, pero baka, for example, ito yung fourth floor mo, okay? Pero ito yung flooring ng elevator mo. So, baka yung difference nila, sabihin natin 2 cm lang yan, yung gap na yan can actually cause, say for example, some accidents. So, problema pa rin yun. Okay? So, kumbaga, parang it doesn't whether it's whether the system responds with something that we intend it to be. Okay, say for example, yun nga, papupuntahin natin siya sa fourth floor. And meron pa ring gap kung tutusin. Okay? Baka that gap is still big enough to cause some accidents. Okay, so it's something that we would like to know. Okay? It is something that we would like to determine. Okay? And another thing that we would like to answer after that is, kung ito yung fourth floor, tas ito, for example, hindi ito yung response nyo. Okay, halimbawa, ang actual na na-reach na nung ano ninyo is something like wala na masyadong gap, okay? Pero ang tanong is how fast your elevator were able to reach that one. Kasi baka mamaya sobrang bilis niya na nahilo na yung nasa loob. Okay, o kaya sobrang bagal naman na nainip naman yung nasa loob. Okay, so we would like to answer those kinds of questions. We would like to determine those things so that we would know if our control system is performing or is performing as expected. Okay, with basically some things like, for example, yung mga tangible things like, for example, user safety and convenience are actually observed, okay, while we do that. Okay? So, ayun. Now, these two can be directly measured. Ito, ma-measure natin ito. Okay? When we determine the response of your system, these two can be measured. Okay? But one thing that cannot be measured, okay, but is very important in the performance of your system is yung stability. Okay? Because for you to be able to have a system that is really usable, that is really safe, and that is really usable, the first thing that you have to ensure is that your system is stable. Okay? So, ito yung importante. But this is something that cannot be that is not really measured directly. Okay? But rather, this is something that number one, exhibited by your system when you are able to measure these two. Kung kaya nyo i-measure yung dalawang yan, okay, that means your system is stable. Okay? Because if you cannot measure any one of these two, okay, your system might not be stable. Okay? And number two, parang kumbaga, all or nothing ito pagdating sa system natin. You can measure both of these if your system is stable, and you cannot measure any of this if your system is unstable. Okay? And an unstable system is unusable system. Okay? Hindi natin magagamit ang isang system that is unstable. We cannot make use of any system that is unstable. Okay? Now, when we are under the system analysis part, we will simply determine these things or this performance levels. Okay? I-determine lang natin siya. Okay? But when we are in the system design, okay, this now becomes our objectives. Okay? Kasi ganito yan. We might have a system at the start. Okay? And assuming that your system is at the start stable siya. Okay? At the start, your system is stable so that you'd be able to measure the time response and the system error. Okay? But you don't find these two to be sufficient for your requirements. maaaring masyadong mataas ang system error mo. Your system error might be too high for your application. Or your time response might not be the one desired. For example, masyado siyang mabilis or it may be too slow for you. So, if that is the case, then we will need to design your system in such a way that we will be producing the desired transient response and or reduce the steady state error. And we want to achieve all of this while ensuring that your system is stable. Still. Okay? Kasi maaaring sa una, meron kayong system, stable na siya. Okay? But you don't want its transient response or you don't want its steady state error or both. Okay? But your problem is, when you redesign your system, okay, your system tends to be unstable kapag pinalitan mo na yung ibang parameters mo. Or pinalitan mo na yung ibang parte ng system mo. In trying to achieve the transient response or the steady state error. Okay? So, in the system design or in our system design, we would like to achieve these three, okay, simultaneously. But still, this is the most important part. This would be the most important part of your objectives. That is, while you are trying to produce the desired transient response or trying to reduce the steady state error, okay, dapat yung system mo would be within the limits for which it would be kept stable. Okay? Is that clear? Okay. So, so ayun. Now, in that process, okay, we would be following this design process steps. Okay, of the process by which we design your system. Okay. So, there are 6 steps here na enumerate. Okay. But I would like you to read them. Okay. And later on siguro bigyan ko kayo ng discussion video regarding dito. Okay. Pero ayan, may mga link naman na nandito which you can actually follow. Okay. But the thing is, if you want to discuss these 6, okay, we would be first determining the physical system and specification from the requirements. Okay. So when you say the physical system, okay, it means the system that you would like to design. Okay. And specification, meaning what would be what are the requirements or what would be kumaga, ano yung mga indicator natin that we are meeting the requirements. Okay? Because there are requirements. Okay? There are requirements for your system. Okay? Pero dapat meron kang indicator. Okay? Or performance indicators. We call it performance indicators. We have performance indicators. Which tells you whether or not you are meeting the requirements. Okay? And these performance indicators come in the form of specifications. Okay? For example, dapat ang rise time niyan is 5 seconds. Less than 5 seconds. Mga ganun. Okay? It means that you know that you are getting dun sa requirements mo. Okay. If your rise time is less, if you are able to measure your rise time to be 5 seconds or less than 5 seconds. Okay. O dapat yung peak time. These are just examples, and then later on we will be discussing these things. Okay. Your peak time should be less than, say for example, 7 seconds. Okay, so dapat it means that your system should be able to reach its peak in less than 7 seconds. So these are your specifications din tawag. And the performance indicators are this. Okay? So you specify your requirements in terms of these things. Okay? So from there, at the start, dapat alam natin yun. What would be your physical system and what would be your specifications, or what are the specifications of your system from your requirements. Okay, the next type of which is you draw a functional block diagram. Okay, when you draw a functional block diagram, it comes in the form of this. Kung maalala nyo yung pinag-usapan natin ito last time. Okay? It should come in the form of this one. So which means that you have to determine what should be its input transducer, what should be its controller, what should be its plant or process, and what should be the output transducer. Okay, and some other things that are required for the system. Okay, so that would be the functional block diagram. Okay, is that clear?
Yes, sir.
Okay, now, so that's your functional block diagram. We will have to pattern your functional block diagram, your block diagram in terms of those closed loop configuration. Okay. Now, the next thing is to transform this physical system into a schematic. Okay. So after you determine what are the relationships in between those components, kasi dito, madedetermine nyo na kasi kung ano yung mga components ito eh. Anong klaseng input transducer meron kayo? Anong klaseng controller meron kayo? Okay? Anong klaseng plant meron kayo? Ano yung mga components na nandito? You will be able to determine all of those. And then you will be able to determine the relationship of those in terms of this functional block diagram. But this functional block diagram may or may not be indicative of how your schematic looks like. Kasi ang schematic is yung actual implementation ng block diagram. Okay, for example, in this functional block diagram, okay, you have a summing junction here. Okay? Pero sa totoong buhay o in reality, hindi ka naman bibili ng component that is a summing junction. You have a circuit that is an equivalent to a summing junction. Okay. What circuit would that be? Anong circuit kaya ang pwede nating ilagay as an equivalent to a summing junction? Any idea? May idea ba tayo kung anong pwedeng circuit ang pwede natin ilagay na magpe-perform ng function ng summing junction? Basically, this summing junction, as we have studied before, adds this signal. The signal coming from your input transducer and from your output transducer. Or basically, not simply add, but actually subtract kasi negative. So, can we think of a circuit that can perform that function that can subtract two signals? May iniisip ba tayo? Oh, yun. Medyo dapat basic na sa atin to kasi ito medyo marami ng electronics na matapos natin pagdating natin dito, so dapat medyo basic na sa atin to. Wala tayong naiisip na circuit na pwede mag-subtract ng dalawang signal. Naalala niyo yung niyo?
Wait, sir, sa op-amp yun, sir.
Ha? Yung alin?
Sa op-amp yun, di ba, sir?
Anong op-amp? Anong configuration ng op-amp? Actually, tama yan.
Wait, sir. Naalala ko eh.
Meron tayong tinatawag na yun, na subtracting or tawag ito? Meron tayong configuration ng op-amp that can actually subtract your circuit. Meron tayong tinatawag na subtraction of subtraction amplifier or adding amplifier. Okay? So we can actually use that. Okay, we have a configuration of op-amp that can actually perform subtraction. We call that a subtracting amplifier. Okay? So ayan, pwedeng gamitin natin 'yan as we can use this as as a circuit that can actually perform subtraction. Okay? So we can kumbaga, these things are not really something na for example, this summing junction na to can be represented by, for example, a subtracting operation amplifier. Okay? But it doesn't mean that this controller is actually a separate entity from this summing junction or from this summing subtracting of amp ninyo. Kasi you can actually have this same kasi ito yung subtracting of amp ninyo. This may be your subtracting of amp plus your controller. You can actually put in some additional components here. Okay, that can actually transform that circuit into this itong part ng functional block diagram ninyo can actually be represented by a certain circuit. Okay, so maaaring isang op-amp lang ginagamit nyo for that too, pero maaari din naman silang separate. Okay, and it doesn't mean that if you see a summing junction here, this can also be, for example, represented by an op-amp. Okay. For one thing, itong disturbance na to is simply basically a concept. Okay. Konsepto lang siya. In this case, for example, this represents an internal internal disturbance or internal noise that is exhibited in your controller circuit. So this summing junction is in no case a physical entity or a physical circuit itself. Kasi nga ito is simply just a concept that you integrate your internal noise sa analysis mo. Okay? So what I'm trying to point out here is that your configuration may or may not be physically represented in your circuit. Okay? Maaaring karoon nito represented by an op-amp in the schematic, pero ito hindi. Same thing with this one. This might not be represented, or more of this is not really represented by again, or this is not put into a schematic by an op-amp, for example. Kasi again, this disturbance is another concept. That of the external disturbance naman that affects your process or your plant. And it's actually affecting the output. Okay? So when you put this functional block diagram into a schematic, what is required of you is to actually know the system in its operation, in its full operation. Para alam natin alin yung component talaga na makikita natin sa loob ng schematic. Okay? And alin yung mga diyan, yung konsepto lang. Okay, which will not really appear on your schematic. So, that is why, sorry. Ayan. That is why, when you transform this functional block diagram into a schematic, you should be really be careful. And one thing that you have to master, one thing that you have to be mindful of when you are trying to do step 2 and step 3 is that you really do have this mastery of you really do have this mastery of what we call yung modeling na tinatawag. Okay? Kasi maaaring alam nyo yung functional block diagram but you don't really know how to transform it to schematic. Okay? Mas mabuti pa nga na alam nyo sana lang yung schematic kahit hindi nyo na masyadong alam yung functional block diagram. But the functional block diagram would actually serve as a way for you to translate this into a computer model. Kung gagawa naman tayo ng computer modeling, this functional block diagram would actually be very helpful. Okay? Because yung schematic naman kasi would require a certain model. Okay? These two, the functional block diagram and the schematic actually are the two things that is required of you to be able to transform this system into a certain model, in which you now can transfer that model into a computer-based model. So that is why kung gagawa kayo ng computer-based model para sa inyong system, record sila pareho. Okay? So that's step 2 and step 3. Step 4 is that you use the schematic to obtain a block diagram, signal flow diagram, or state space representation. Okay? When you say when you have this block diagram, or when you say signal flow graph or state space representation, this now calls you to do a mathematical model. This now requires you to translate the schematic and the functional block diagram into a certain equation, okay, that would represent the system. Okay, normally the easiest way to be able to get around this is to be able to translate each block into a model. Okay, yun nga, kung meron kayong functional block diagram, something like this one, okay, each of this would have its own mathematical model. Each of this, magkakaroon siya ng tag-iisang mathematical model. Okay, that's the easiest way to do around it. Okay, although minsan hindi rin ganun kadali yun. Okay, it actually depends on how complicated the system is and how complicated your components are. Okay, so this step 4 would now put your system into a mathematical model. Yun yung parang pinaka-essence ng step 4. But in this case, you have 3 approaches here. Okay, 3 approaches in which your system can actually be put into a mathematical model. Okay, although we will be discussing 2. Okay, and we will simply use I will be introducing you to 2 of those approaches. Okay, 2 of those approaches. Pero isa lang talaga yung gagamitin natin. Introduce ko lang kayo dun sa dalawa. Okay, pero dun sa dalawa na yun, isa lang yung talagang gagamitin natin. Okay, and itong dalawang to, ito yung gagamitin natin mostly in the future also. Yung block diagram or using the program. This is state space representation, okay, is one thing that which I will be introducing you to, but we will not be extensively using. Okay, gagamitin natin gagamitin natin ito sa laboratory activity niyo. You might have a laboratory activity that would be dealing with state space representation. Okay, so yun. Now, if you now have a complex block, or if you have multiple blocks, something like this one, something like this one, na marami kayong blocks na makikita dyan. Okay. We would like to reduce that block, or those blocks, or those block diagram, into a single block or a closed loop system. Into a system, okay, having what we call a unity feedback. So, yung ganitong block, ganitong kakomplikado na na system natin, okay, can be reduced, okay, can be reduced into a single block, okay, o kaya can be reduced into a block having a unity theta. So either we reduce it to here or to here. That is what the step 5 is all about. Okay? And then finally sa step 6, we will try now to analyze and design. Okay? So first we will try to analyze the system. Okay, determine its we will characterize the system, determine its transient response and steady state error or system error characteristics. And if we are not satisfied or we are not meeting the requirements for your system, we will be trying to design, okay, or redesign the system in order for us to meet those requirements. Okay? Is this clear? Any questions pa so far? Wait lang.
Wala naman po.
Wait lang. Okay. So, ayun. But then again, what you need to think of is that hindi naman ito yung hindi naman these steps is not actually linear. Okay? Sometimes, for example, sa approach natin, we will try to skip first step 5. Kung magagaling sa step 4, mag-skip tayo ng step 6. Okay? And then babalikan natin itong step 5 in a linear topic. And then babalik tayo ng step 4, pupunta tayo ng step 6. Pupunta tayo ng step 5, tapos pupunta tayo ng step 6. Something like that. So, kumbaga, in our lesson, this is not really linear. And in actual practice, this is not actually a linear process. When you say linear process, ibig sabihin, straightforward na ganito mo siya gagawin. No? You would not be doing that in that manner. Okay? And especially, may mga times that you would be actually not performing these steps in this really exact in this exact process. Okay, for example, maaaring from here, okay, maaaring or halimbawa from here after obtaining a functional block diagram, you would be able to skip this part. Okay, and then instead of actually doing all of this, okay, you would be trying to come up with a computer model. Ibig sabihin, si computer ang pag-generate mo ng model. The computer itself or the software itself would actually obtain the model for you. Okay? Pero may kailangan i-input dun sa excuse me. Meron ka kailangan i-input dun sa sa system mo. Okay? Like for example, you need a set of input and output signals. Okay, you need a set of input and output signals. Okay, for your computer, for your software to come up with a model by itself. Ibig sabihin, kailangan mo na meron ka ng system ngayon, na-build mo na yung system. Meron kang test input signal. Kunin mo yung output niya. Yung input-output pair ngayon ng signal mo, nung system mo. Okay, ilalagay mo dun sa computer mo. And then the computer using those set of signals, siya yung mag-generate ng computer ng model mo for that system. Okay? And then from there, you can also use the computer to analyze your system. Okay? So that's one approach na especially if you have a computer if you have a software that can actually do that. Okay? So that's one thing that you need to know when it comes to modeling your system. Okay. So in this case, sinasabi nga natin that one thing that you have to perform is um, after performing step 1, step 2, and step 3 is to this one. Okay. That is you obtain a block diagram, a signal flow, or a state space representation in which we would like to get a mathematical model for your system. So this particular part of our lesson would actually deal with that. Okay, would actually deal with system modeling. Okay, and sabi ko sa inyo, I will introduce you to two main approaches in modeling systems. Okay, so but we will focus on one of those two. Okay. Dito, ayusin natin siya. Ayan. So, the two approaches are the classical approach, okay, or the frequency domain approach, or what we call the transfer function approach. Okay? The next approach is yung modern, okay, the time domain approach, or the state space approach. Okay. Yung classical approach, basically, this deals with with the Laplace transform model. Okay. Now, I'm pretty sure na lahat kayo ay tapos na ng advanced engineering mathematics, so you are able to study what Laplace transform is. Tama ba ako?
Yes,
Yes, sir.
Okay. So, in that case, since alam niyo na yung Laplace transform, we'll actually study Laplace transform in the next topic. Okay. So, pag-uusapan natin siya. Okay. But then, yun nga, expected na dapat alam natin itong Laplace transform. Okay. Now, next approach na I would introduce you is the time domain approach. Okay. We have a modeling approach called the state space representation. Now, the state space representation consists of a system of first order differential equations. Okay. So, system meaning this is something like meron kang, for example, kung meron kang second order system, for example, kung meron kang second order system, you have to break down that second order system into two first order systems or first order differential equations. When you say a system is second order, it means that your system is represented by second order differential equation. Okay, its input-output equations or input-output relationship is represented by a second order differential equation. Yun yung sinasabi nating second order system. Okay. In state space modeling or in state space representation, you would have this second order differential equation broken down. Okay. We need to break it down into two first order differential equations. Okay? So that is why it's called a system. Kasi it means that you have multiple differential equations. Okay? You just don't have one, but multiple differential equations. And all of those differential equations are of first order. Okay? So, ngayon, actually, I'm discussing now this Article 2.1. Okay? So, sige, i-shift ko na yung discussion dito. Okay? So, as I have said in the previous discussion, dalawa yon, yung isa, ay gamit ng frequency domain. Okay? Or would use frequency domain. And the other one would use, or it would use Laplace transform. And the other one is yung time domain. Okay, and would use differential equation. Okay. So in terms of the Laplace transform, okay. Basayan to. In the previous discussion, the analysis and design sequence that included obtaining the system schematic was discussed and demonstrated in this step for a position control system. The step is to develop mathematical models from schematics of physical system. So we have discussed two methods. I am discussing two methods now. Number one is yung transfer function, okay, and the other one is yung state equations. Okay. It should be remembered that in any approach that you would use, okay, in any approach that gagamitin natin, okay, the first step, okay, is to apply the fundamental physical laws of science and engineering. So, if we would be starting again, if you would be starting the modeling, okay, in its very basic and fundamental sense, okay, magsisimula kayo sa mga basic laws ng science and engineering. For example, if you are talking about electrical networks, you would be using Ohm's law and Kirchhoff's law in order to come up with models. Okay? For mechanical systems, you would be using Newton's law or Newton's laws of motion. But again, this applies if you are to come up with a model na manggagaling sa schematic. Okay? Again, in practice, you might not be going through these rigorous steps anymore. Especially, number one, if meron kang computer or meron kang application or app that can actually come up with the model for you. Okay? Or number two, yung literature that models this kind of system are actually existing. For example, kung nandiyan naman na yung model for a certain system, like for example, a ball and beam balance, okay, you don't need to really come up with the model by yourself, okay, kasi nag-exist naman na yung literature that tells us or that discuss how these models are obtained or how the models for the systems are obtained. Okay, we would be but in any case, okay, when you are starting from scratch, yun yung tatandaan natin. Okay? Now, from previous courses, it is seen that a differential equation can describe the relationship between the input and the output of a dynamic system. If you have a dynamic system, when you say a system is dynamic, its output changes with time. Okay? The output of the dynamic system changes with time. Okay. And if you have a system that is dynamic, that also means the relationship between the input and the output signals are described by a differential equation. Okay. Now, the form of the differential equation and its coefficient are a formulation or description of the system. Okay. The form, whether your system, whether it is of what order, okay, if it is linear, okay, if it is homogeneous or not, okay, depends on the nature of the system. Okay, coefficients of this differential equation actually comes from what we call yung parameters. Okay, nanggagaling yan usually sa parameters ng system. Okay, and we'll discuss parameters, pero basically, ang pinanggagalingan ng parameters ay yung mga values ng mga components that you use for your system. For example, if your system is electrical, meron niyang resistor, for example. Meron niyang resistors, meron niyang capacitors. And in some cases, meron niyang inductors. Okay? Yung mga values niyan are actually called parameters. For example, if your resistor is 10 ohms, and then your capacitor is 1 farad, okay, yung inductor mo is 0.1 Henry. These are what you call parameters. Yung mga yan what you call parameters. And depending on the system, marami pa kayong pwedeng ilagay as a parameter dun sa system. Okay? So basically, a parameter, in its basic sense, a parameter can be described as something that is constant to the system. Constant, okay? But not really constant kasi kapag yung part na yun, yung system, or yung component na yun ay pinalitan mo, okay, pinalitan mo siya, hindi na siya, iba na yung value niya. Okay, so basically, constant siya for a particular situation. Okay? That is how we define a parameter. So which means, for example, pag yung motor, okay, yung motor mo, meron yung mga certain set of parameters. May mga values yan that is put into your equation as a parameter or as parameters. Ngayon, pag nagpalit ka ng motor, yung lumang motor ay pinalitan mo ng bagong motor. Itong mga parameters na to would actually be changing. Okay. Maaaring hindi magbago yung forma ng equation mo. Pero ang magbabago, yung mga coefficients niya. Okay? Is that understood kung ano yung role ng parameters sa model mo? Okay, mukhang dalawa lang nag-reply. So, ayan na. Kumbaga, pag nakakita kayo ng mga coefficients sa model natin, whether it's in the form of the differential equation or of the transfer function, yung mga coefficients na makikita nyo doon are actually coming from the parameters. Okay. They would actually originate from the parameter, from the components. Sorry, from the those coefficients are called parameters, and these parameters or these coefficients would actually originate from the components of your system. So later on, mapapansin nyo naman yan. Okay? Now, now here's the thing. Pag meron tayong system, okay? Pag meron tayong system, the input to the system or the signal, okay, that is an input to the system, okay, is designated as R of t. R is for R of t. It means R as a function of t. Okay, and that R stands for actually reference input. Kaya yung signal na yun, okay, we refer to that as the reference signal. Okay, pero we use the notation R of t to represent the input signal to your system. Okay, yung C naman to represent the output. That C as a function of t. C here stands for control variable. It means that it's the signal that represents the value of the control variable. Okay. Now, when we describe your system in this manner, okay. Again, your C of t is related to the input signal or the reference input via a differential equation. Okay, so yung relationship ng C of t at saka ng R of t is basically controlled or is basically described using a differential equation such as this one. Okay. Ganyan yung itsura. Okay, ganyan yung itsura ng relationship between C of t at saka ng R of t. If we describe your system in this manner. Okay. So as you can see, medyo may pagka-komplikado siya, di ba? It actually is very complicated with that one. Okay. What we like to do with this one. Ayun. What we would like to do with this one, okay, is that ang gusto sana natin is there is a simple way to actually relate these two. Okay? And that simplest way is actually done, okay, using Laplace transform. Okay? So the easiest way to actually relate the two, okay, is by actually obtaining the Laplace transforms of R of t and C of t. Okay? And in that case, we would be able to describe, ito makikita nyo to in a later topic, that we would be able to um, describe that system, that equivalent system, in terms of the Laplace transform R of S and C of S as your input, or the transformed input and the transformed output itself. And using this, we would be able to characterize this system, okay, using the notation G of S. Okay, and that we will find that C of S equals R of S times G of S. So, mare-reduce natin yung problem natin in a simple product, yung simple product notation. Kumpara nyo yan dito. Okay. For you to be able to relate C and R in a single equation, you need to describe them using a differential equation. Okay. Pero, using the Laplace transform, we can reduce that problem in this manner. Magiging simple product na lang siya. Okay? So, that is how we will be able to use, and G of S here is what we will call later as the transfer function. Okay, we will use the term transfer function to this G of S, which characterizes your system. Okay? Yan yung transfer function approach. That is how we will perform the transfer function approach. Okay? Pero there is a problem with that one. Okay, there is a problem with that part. Okay. Okay, pag-usapan natin yung advantage muna. A major advantage of frequency domain modeling, yun nga, yung transfer function approach, is that they rapidly provide stability and transient response information. Okay. Kumbaga, the frequency domain modeling is very intuitive. It is very intuitive, which means that using the transfer function itself, you would be able to find stability and transient response information without really computing so much things. Okay. The good thing about the transfer function approach is it's that you can obtain various information about the system without actually doing very complicated mathematical computations. Yun yung pinaka-advantage niya. So yun nga yung intuition. It actually provides intuition to the system designer. Okay. The primary disadvantage, okay, is its limited applicability. Okay. Which means that there are certain restrictions to the system that limits the application of in which systems can you actually apply these things, or this analysis or this approach. Okay. It can be applied only to linear time invariant systems. Okay, or any systems that can be approximated as such. Okay, ibig sabihin kapag ang system mo ay non-linear, okay, or it would exhibit non-linearity, then your approach would actually break down. Hindi na niya mare-represent ng tama yung system mo kapag yung system mo is non-linear. Okay. There are systems, most of the systems that we have today are actually non-linear. Okay. But meron tayong pwedeng gawin ng mga approaches, like for example, linear approximation to a non-linear system. Okay. Which involves medyo mga mathematical processes. Okay. Yung iba doon ay, or yung marami doon ay hindi natin masyadong aaralin. Okay. Because in this case, we would assume that all of the systems that we will try to analyze are actually linear. And for a start, or for us to study your systems, okay, in terms of yung kumbaga yung entry level natin sa pag-aaral ng control systems engineering. Or when we start to kumbaga parang ito yung natin, control systems engineering 101 natin. So we start with this one. This is a very good start. Okay. Pag medyo halimbawa, mag-masters kayo at meron kayong advanced na study ng control systems engineering, medyo dun yung pag-aaralan yung mga mas advanced topics. Pero for us, since we are on the entry level or in terms of studying this system in a very basic level, we would use we would assume that all of the systems that we will discuss are linear and time invariant. So para hindi rin masyadong magulo yung discussion natin. Okay? But remember this, with an increasing design scope, the modern or time domain approach of modeling system is devised. Okay? The state space approach is a unified method for modeling, analyzing, and designing a wide range of system. Kumbaga, ang modern approach or ang time domain approach has no limit in terms of applicability. Kumbaga, parang wala tayong titingnan na restriction on which systems can the approach be applied to. Hindi katulad ng transfer function approach. Okay? It can model nonlinear systems and systems with zero initial conditions because the model or the method by which it can be done can actually include those things such as yung non-zero initial conditions and yung mga non-linearities niya. Okay? Time-varying systems, okay, and systems with multiple inputs and multiple outputs can be compactly represented in a state space model. Okay, so ang problema rin natin sa transfer function approach is that it can only model single input, single output systems. Isang input at isang output lang yung kaya nating i-model at one time. If your system consists of multiple inputs and multiple outputs, kaya naman natin siyang i-represent using the transfer function approach, provided that the entire system is actually linear. Number one. Okay. And the more difficult part of it is that kailangan niya siyang mag-produce the transfer function in as many pairs of input-output that can be deduced from the system. For example, yung system mo has two inputs, okay, and two outputs. Halimbawa, R1, R2, C1, C2. Ilang pairs of input-output ang pwede kong buuin galing dito? For example, isang pair is yung input niya is R1, ang output niya is C1. That's one pair. O ilang pairs ang mabubuo ko galing dito?
Dalawa, sir.
Dalawa, sir.
Ha?
Dalawa.
Dalawa lang ba?
Dalawa.
Yan, isa na to. I-enumerate nyo pa yung mga mabubuo kong pairs nito ng input at saka output.
R2, C2, sir.
R2, C2. Paano pa?
R1, C2, sir.
R1, C2, tsaka
R2, C1.
R2, C1. O ilan na?
Apat.
Apat. Okay. There are four input-output pairs that can be deduced from this two input, two output system. It also means that it requires four transfer functions for you to be able to fully describe this system. Okay? So, in terms of the transfer function approach, you need four transfer functions to describe the entire system. Pero, you only need, in terms of state space representation, this can be compactly represented by the state space representation using one set of equations. Okay? Pwede niyang i-represent yan using a system of four first order equations. Lahat na yan. Kaya lang, for you to be able to solve this, kailangan nyo ng knowledge ng linear algebra. You need a profound knowledge of linear algebra for you to be able to solve this kind of problem. Okay? Which in our case, di man natin kailangan ganun komplikado pa yung kailangan natin alamin. So that is why we would stick with transfer functions. And most of the systems naman na i-analyze natin are single input, single output systems. Okay? So is this understood?
Yes, sir.
Okay. Saglit lang kukuha lang ako ng water ko
Sige lang, sir.
Okay. Wait lang.
Lance, what is your question?
Hello. Ayun. Nadidinig ako?
Yes po, sir. Dinig po.
Okay. So that's how we will proceed, no? Basically, what we need to study basically is yung tinatawag nga nating transfer function approach. Okay, in which we will be dealing with Laplace transform in order to be able to get that. Okay, so we will first have a little review of what the Laplace transform is. Okay? So the Laplace transform satisfies the requirements for the convenient mathematical representation of your systems using transfer function. Okay, as we discussed in the previous topic. Okay. Furthermore, the Laplace transform makes the relationship between systems algebraic. Okay, so again, instead nga na ganito, yung itsura ng description ng system ninyo, we will be able to reduce that description into something like C equals R times T. Basically, that's the input times the transfer function. And that will be your output, or the transform of your output. So that is how we will be able to that's how we will be able to describe your system after using the Laplace transform. Okay. So the Laplace transform is defined as this way. Okay, that's the integral of the f of t times e raised to negative s of t d of t. Okay, from 0 to positive infinity. Okay, so we are talking here of what we call the one-sided Laplace transform. Okay, it means kasi that we will be just performing this integral from on the positive half of your number line. Okay, ipe-perform na natin siya sa positive half of the number line. Okay, ano mga implications nun? Number one, it assumes that your function, the function is 0, okay, for the values of t less than 0. It means for the negative values of t, ang value ng function nyo ay 0. Okay, yun yung unang assumption. So it also, mamaya i-explain ko ano yung implication dun sa ating system. Okay, pero basically, that also requires us to have your system. That requires your system to be to have zero initial conditions. Okay, yun yung pinaka-implication nun. Dapat yung system niyo is considered to have zero initial conditions for you to be able to use the Laplace transform or the one-sided Laplace transform in this case. Okay? Now, S here, okay, is our complex variable. Okay, S here is a complex variable and is equal to sigma plus j omega. Okay? So, later on, magkakaroon ng significance natin itong sigma plus j omega na to. Okay? Now, the function f of t is in time domain, basically, and has the Laplace transform f of s in s domain. So, ibig sabihin, you have f of t as a function in time domain. So, that means that is your signal, okay, as it varies against time. Okay? Yun yung ibig sabihin nito, f of t. Okay? Now, when you take the Laplace transform of this one, okay, okay, it means that you are changing the domain of the function. So instead na siya ay function na in t, okay, your function now becomes a function in s. Okay? It means that your function now is a function in s. So anong ibig sabihin nun? Una-una, pagka nagkaroon kayo ng Laplace transform, siyempre, kung ang function mo ay function na in S, it means that f of s should not contain, or for example, if you have f of s here, dapat yung function mo dito, or yung expression mo dito, dapat wala ng t. Okay, it's something that you would have to be careful about. Kasi marami sa mga students, ang nakikita ko is that when they do, or when they perform the Laplace transform, or when they obtain the Laplace transform of a certain function, yung f of s nila, meron pa ring t. Okay, which is, alam na natin na kagad, dun pa lang, mali na yun. Kasi nga, function na siya of s eh. Okay, and if that function is a function of s, okay, then, dapat wala tayong makikita ng t dito. Okay, if you actually perform this integration, okay, you would be able to notice na mawawala talaga lahat ng t sa part na to. And it's basically because mag-substitute kayo ng t. Okay, after you perform the integral, you would have to replace t, okay, as approaching infinity and t approaching 0. Then isusubtract nyo kasi yun. Okay, and that is why may iwan lang talaga dyan yung s. So that is why when we have a function of f, when we have here the function of your s, dapat wala ng t doon sa expression na yun. Is that understood? Okay. Ito. Okay. So, these are the Laplace transform table. So pansinin niyo dito, under the f of s part, okay. Wala kayong makikita diyan na kahit isang sagot diyan na merong t. Okay? That is because nga these functions are all functions of f of s na. F of s are all functions in s. It means the variable there is s alone. Okay? So therefore, wala na kayong makikita t dyan sa part na yan. Okay? So, what we can see here are the pairs of Laplace transform. I'm sorry. Here are the pairs of Laplace transform that for function f of t, ito yung magiging equivalent niya na transfer function, na Laplace transform in S. Isa pa ha, it doesn't mean, for example, that delta t, or for example, you have here t, u of t here, is actually equal to 1 over s. Hindi yan, hindi yan totoo. Okay? You have f of t, or if f of t is given as t u of t, okay, its Laplace transform, or the Laplace transform of f of t, okay, which is f of s, is equal to 1 over s. Pero it doesn't mean that t of t is equal to 1 over s. Okay? This is very wrong. Yung tatandaan niya, this is very wrong. Okay? So, parang ito yung mas tamang statement dyan. If f of t is given as this one, then f of s is this one. And it doesn't mean that these two are equal. Okay? Transform kasi yan. When you say transform, you are changing, okay, or you are changing the domain of the function. You are remapping. Okay? Transformation transforms means remapping. Okay, when you are remapping, it means that kung ito yung function ninyo, okay, in terms of the t domain or of the time domain, so ibig sabihin yung x-axis nyo dito is in time domain. Okay, when you remap this function in another domain, okay, it means that yung x-axis nyo dito magiging s na. And isang point dito can actually be put in another point here. Say for example dito. Another point here can actually be put in another point here. So may iba yung yung itsura ng function niyo. Okay? So they are not equivalent functions. So that is what I mean. These are not equivalent functions. In fact, magkaiba yan. Because they have different domains. Okay? Is that understood?
Yes, sir.
Yes po, sir.
Okay. Saglit lang. Okay. So, ayun, yun yung tatandaan nyo dyan. Now, we will not, kasi tapos naman na kayo dito sa advanced math, I suppose. So, what I would like to emphasize here is that instead of actually going through this integral, which is what you have done in your in your advanced math. or in your advanced math course. Hindi tayo dadaan sa integral part. Okay? What we will simply do is we will use this table in order for you, kasi meron na tayo nung mga simple functions or mga basic functions. Ano yung Laplace transform pair nila. Okay? But what we will do, what we will do is instead obtain yung Laplace transform ng mga functions that are not in this table. Okay? If they are not on this table, kukunin natin yung Laplace transform niya using this table and these properties. So, gagamitin natin itong table na to at saka itong mga properties na to. Okay, so as I give an example later on, i-point out ko dito which of the properties that I would be using. Okay, and one more thing that you have to remember about this table. Yung U of t, is basically this one. Okay, U of t is what we call the unit step function. This is the unit step function. Okay. Now, what we will try to do is, since, again, as we said, na yung Laplace transform nyo is defined on positive values of t. Okay. And that, ang unit step function nyo is basically 0 naman for negative values of t. Then we can use this other half of the definition for your U of t. Okay, gagamitin natin itong second half ng definition niya, which is 1 for positive values of t. Which means, ito, pwede natin equal na to basically sa 1. Okay, so, ibig sabihin, yung Laplace transform ng 1, ng f of t equals 1, is basically 1 over s. Ito naman, since again, u of t nyo is equal to 1, then t times 1, okay, t times 1, basically t. So, which means the Laplace transform of t is 1 over s squared. Naintindihan niyo yung gusto kong i-point out dito?
Yes, sir.
So this is basically t raised to n. Okay, this is e raised to negative 80. This is sine omega t. And this is cosine omega t. So, kumbaga, itong u of t, i-treat na natin siya as 1. But, delta t, this is read as delta t, no? This is not, wala tayong equivalent number dyan. Kasi yung definition ng delta t ninyo, or the unit impulse signal, or unit impulse function, is basically infinite yan. Okay, for t equals 0. Okay, and 0 yan if t is not equal to 0. So medyo iba yung definition niya sa u of t o sa unit step function. So that is why we will leave it as it is. Later on, I'll give a practical, a more practical description of what delta t or the unit impulse signal is. Okay, bibigyan natin ito ng mas ibang definition. Mas descriptive, kumbaga, na definition. Okay? So, ayan. Okay. So, let us try to find the Laplace transform of this one. So, this is e raised to negative 80 cosine of omega t plus theta. Okay? So, in this case, tatandaan lang natin that variables other than t here are constant. Ibig sabihin, yung a, yung omega, at saka itong theta, these are all constants. The only variable that we have here is t. This t and this t. Okay? So how do we find yung Laplace transform nito? First thing, we take note that wala yun sa table. Okay? We take note that this function is not on the table. Wala yan sa table, di ba? Makikita natin. Tama?
Yes, sir.
Okay. Now this is what will happen. We will reduce this, or we will transform this this function into something, or into an expression na makikita natin yung 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 transform nila dun sa table, and at the same time magagamit natin yung properties dito. Okay? So, first thing, para magawa ko yun, unang-una, let us expand this. Okay? Kasi unang-una, wala kayong makikita ang cosine at saka sine dyan na merong addition of angles. Okay? So, since walang sum of angle na function dito, okay? We would transform this part, okay, using yung sum of angles formula o sum of angles property ng cosine function natin. Okay, so you can verify that dun sa mga table of identities ninyo. We can reduce this as, or we can transform this as cosine of omega t, okay, cosine of theta minus sine of omega t, sine of theta. Familiar ba kayo dyan? Dito sa to?
Yes, sir.
Okay, so sige. Then, expand natin siya. Okay? So you have e raised to negative 80 cosine omega t cosine theta minus e raised to negative 80 sine omega t sine theta. Okay. Again, as I said at the start, variables such as a, t, and theta are constants. Okay? Sorry, a omega pala, hindi pala t. A, omega, and theta are constants. Okay, that should imply that itong cosine of theta na to at saka yung sine of theta na to are constants. Because if theta is constant, cosine of theta is also constant. Same thing with this one. If theta is constant, sine of theta is also constant. Maliwanag ba?
Yes, sir.
Okay. Now, in that case, by linearity, okay, tingnan nyo ito mabuti. Number 2. Okay. Makikita nyo dito that the Laplace transform of a constant times a function, okay, is equal to the constant times the Laplace transform of the function. It means I can take out the constant and then obtain the Laplace transform of what is remaining. Okay. It means now that if this is constant and this is your function, okay, para makuha ko yung Laplace transform nito, okay, for me to be able to get the Laplace transform of this one, okay, so the Laplace transform of f of t, which is now f of s, okay, for this one, I would obtain yung, kasi lalabas ito, function to kasi ito constant. So I can simply take out the constant, okay, and then obtain the Laplace transform of e raised to negative 80 cosine omega t. Yan yung linearity na number 2. Okay? But also, at the same time, I would be applying yung linearity number 3. Ano ba yung linearity number 3? It means that if you have two functions, okay, you have to obtain the Laplace of the sum of two functions. Then you can simply just obtain the Laplace transform of each terms and then add them up. So, in that case, ma-apply ko yan dito kasi isang term ito isang term din ito. So, pwede kong i-apply yung linearity in that case. Kukunin ko yung Laplace transform nito, kukunin ko yung Laplace transform nito. Okay? Is that clear?
Yes, sir.
Yes po, sir. Yes po.
Okay. So this would be written as minus, again, in this case, para ma-apply ko yung linearity, the number 2, I would have to take out sine of theta, and then kukunin ko yung Laplace transform ng e raised to negative 80 sine of omega t. Okay? Is that clear? Okay. Now, how do we get now the Laplace transform of this one? For example, this one. In this case kasi, again, wala pa rin to sa table ninyo. Because in your table, you only have cosine of omega t. Okay? But you don't have e raised to negative 80 cosine omega t. Wala kayong ganyan. You don't have that kind of thing in your table. But here's what we do. We look at property number 4. Okay? If you look at property number 4, it means that you have a function multiplied to an exponential. It's e raised to negative 80 times e raised to times f of t. Okay? And that function becomes f of s plus a. Anong ibig sabihin ng f of s plus a? It means we get f of s. Kung natin yung Laplace transform ng f of t, so that's f of s. And then we replace s with s plus a. Okay, we replace s with s plus a. A here is whatever the exponent of this is here. So that is what we call the frequency shifting theorem. Okay. So here, I would apply the frequency shift. So we will apply by frequency shift theorem. This is number 4 of your property. Okay. Ito yung f of t natin. This is your f of t. Okay. What I would want to do here is to find the Laplace transform of this one. Ng cosine omega t. Now, what is the Laplace transform of cosine omega t? Okay. Based sa table, ito siya. That's s over s square plus omega square. So, which means, the Laplace transform of this one is s over s square plus omega square. But, since this is multiplied to an exponential, I would have to apply the frequency shift theorem here. So what I would do is I would replace s with s plus whatever this is. So since this is negative a, so that's plus a. Dahil negative a siya. So I'll replace s with s plus a. Okay? So yun yung Laplace transform ngayon nito. This one is the Laplace transform of this one. Pero hindi pa ako tapos dito because I still have to replace s with s plus a. So this is to be multiplied by cosine theta. Okay, and that would be your f of s. Okay, same thing with this one. Okay, so this is minus sine of theta. Again, by frequency shift, okay, I would have to take the Laplace transform of sine omega t. And if you check sa table mamaya, okay, that would be omega over s square plus omega square. But I would have to replace s here with s. Again, since this is negative 80, I would have to replace that with plus A. So this is how it would look like. This is cosine theta times S plus A. Again, i-replace ko yung S ng S plus A. Divided by S plus A squared plus omega squared minus sine of theta, okay, times omega over S plus A squared plus omega squared. And then, that will be your f of s. If you actually simplify this, okay, if pag simplify nyo yan, you will be able to get this. Anyway, ang gagawin nyo lang naman dyan is basically you have the same denominator here. Okay, so that can be simply written as f of s pareho naman itong denominator ninyo. Okay, so I'll have that common denominator there. Okay, now the numerator here is basically s plus a times cosine theta minus this omega sine theta. That would be your Laplace transform. And notice na wala ng t yan. There is no t here. So therefore, you know na at least meron kang medyo konting proof that your answer is correct because there is no t on this expression. Because you have f of s. Okay. Is this clear?
Yes, sir. Yes, sir.
Okay. Now, so since it's 7 o'clock, so time na natin. I'll continue with this one. In the next example now, we would be solving the inverse Laplace transform of a function. That is now, we will find the f of t whose Laplace transform is this one. So yun naman yung problem ng inverse Laplace transform. Okay, so we'll do that next meeting sa Friday. Okay, so ayun. Okay, so we'll dismiss the class now. I'll see you on Friday na lang. Okay?
Thank you po, sir.
Thank you, sir.
So, kindly leave the meeting na lang.
Okay po, sir. Thank you po, sir.
Okay.
Sige po, sir. Thank you po.